All right, this is going to be a video on creating a stack, a queue, and then also sorting a customer list, and also adding, using transactions for priority queue. So we're going to be building your own priority queue. Actually, you know what? The priority queue stuff might be in another video. Let's go ahead and start with stacks and queues. We're going to build our own. The standard template library has them, of course, and of course you've got plenty of research material out there, but I've always been a fan of building it myself. That way I have full control over everything. And of course you can use these, anything that we show you on the videos in your homework and your project. So what we're going to do is we're going to actually take that customer list that we created in previous videos, and I'm going to create another project, and we're going to bring in some materials from there. Probably will be doing a transaction type implementation shortly. So let's go ahead and get Visual Studio started, and we'll call this one stack and queue. Now the thing about stacks and queue, the whole idea is, especially when I was learning about stacks and queues, I thought that they were something different than what I already knew. So essentially a stack and a queue is what you already know, but just how you use it. And what I mean by when I'm saying what you already know, well, you know how an array works. You know how a linked list works. So you can have a stack that implements or uses an array, or you can have a stack that implements or uses a linked list. The same with queues. A queue uses an array or a linked list to be implemented. So essentially you're just doing it in a specific way. So a stack is what we call first in, last out. And that means when you add an item into the stack, it's going to be the first item into the stack will be the last item out. So they have special functions that you use called like push and pop and whatnot. Oops, did I open Visual Studio? I wanted to just create a new project here. So we'll just go ahead and go to File, New Project. Essentially you can create a stack using an array, just as long as you add items and remove items from the stack in a first in, last out manner. So they've got some special names for them, and they call it push and pop. And then top. So when you push, you put something on the stack. When you pop, you take something off the stack. And the top is the one that's ready to be popped. So we're going to actually implement that with our linked list that we've created in previous videos. So this is going to be stack, queue, and sort. And then we will do, I'll probably add another video for transactions where we use the same code base. Or if we get along far enough where we don't take more than an hour, we'll probably get it done in this video. Okay, so let's see. I think we're going to go ahead and roll with this. And I'm going to bring in that code from our customer list. And then we're going to inherit from our linked list and add functions push, pop, and top. And they have to work in the first in, last out manner as a stack is. And a queue is basically like a grocery line store. So that acts in the manner of first in, first out. So the stack you can think of at a buffet being a stack of plates. You put plates down, and the first plate down is the last plate used. So let's see here. Now we're going to go ahead. I'm going to go find those files here from one of our last videos, and that is, I believe, the customer list is the last video that we had. And I'm going to take all this stuff. Looks like we got transactions. We got a save. So we got everything. I think we got everything we need here to go ahead and get our implementation of a stack and a queue. And it's simpler than you would think. It was, to me, it was like, oh, geez, this is one whole main thing to learn. It's after linked list, and whoa, linked list was just too much. But no, actually, this is a really simple 2 chapters that you can get through without much problem at all. So let's see, we got our code that we need, and then let's go ahead and put it into the new project that we're working with, and then we'll add those as references. I'm going to put the DAT. I'm going to put that as soon as I build this project. The DAT will go into where the executable is at. Okay, so let's go ahead and add these files. Existing item, and let's go ahead and grab all these guys. Oh, it's shift, not control. Oh, that's too much. Oh, it is control. Okay. Okay, I think that's, oh, one more. Okay, those guys are in. We have our main, and we're going to take and make this customer list type something else. So I'm going to go to add. We're gonna build our own stack. We'll call it C stack because we're building a list of customers for our stack. Now you can also build this stack so it's templated, but you know, this is more I would say customized. So you can make your own stack in this manner, inherit from linked list. And you know what? Actually, let's do it that way. Let's make it templated. Let's not do a customer stack. No, we want to do the customer stack so that we can sort. Because I want to show you how to do a stack and then sort it. No, we'll come back to the customer list and we will sort that one. That's what we'll do. We'll just make a templated stack. Okay, so I'm going to go here to add a new item to the project. And we're just going to do a header file, and this is going to be called my stack. I don't know. Yeah, my stack. That's fine. Okay, so we're going to steal some code because we're actually going to implement this stack with a linked list. So what that means is that we're going to inherit our stack from a linked list, but we're also going to make it templated. So what we're going to do is we're going to do this, Control C. And then we got Control V. Okay. Okay, now what changes here is, of course, the name. It's going to be my stack. And we need to include linked list.h. And here we are still going to inherit from the linked list, but our template T that we send to the linked list, because we're making this a stack type, so this is going to be my stack, and we're making it templated so we can be a stack of anything, essentially. So what we'll do here is go here and grab this code for templating. It's in linked list, and I just don't feel like looking it up, so of course just grab that. Probably could do that from memory, but in any case, here we go. And this is going to be a templated class that inherits from a templated class. So that means that since the class T, when we instantiate a my stack, we're going to declare what data type we're going to put on that stack, which we'll probably do customers on the stack. So this is actually when we're in main, we're going to instantiate. Let me go ahead and just get rid of this stuff. We will. Yeah, well we got that code in other areas, so we'll just take this stuff. And I'm going to go ahead and just comment it out because when I get to the customer list, sorting the customer list, we're going to need that. Okay. Well, seems my computer is slowing down for some reason. Okay. All right, we're good. All right, so when we instantiate the stack, we're going to say my stack. And let's do it. We're going to bring this stuff up eventually. My stack. Actually, you know what? Let's bring this stuff in right now because we're going to put these on the stack. And then we're going to instantiate the stack. C stack. And it's going to be a customer stack. We can make it anything we want. Okay. And now instead of add rear, we're going to be using something totally different. Okay, and then this is going to have to be, what do we call it? MyStack.h. Okay, so this is main, and when I instantiate a stack, I'm going to instantiate a customer. Found include customer.h. Okay, and I believe customer just got ID in it for now. We didn't really do any get and set for first or last name, which I'm going to be changing shortly and showing you kind of different ways of doing that. We also don't have a default constructor, so what we'll do is we'll put in a default constructor and an overloaded one. But that'll be coming up after we test the stack. So the stack is going to inherit from linked list, and when we instantiate this in main, we're saying that T is customer. It could be anything, of course. So when it comes into the stack as customer, it goes in here, and this T becomes customer. So, but we use the name T because we're doing templates. Okay, so now our stack is ready to roll, and you know stacks are so stupid simple. Once you get the linked list done, you pretty much have it because it works in a first in, first out manner. So what you got to do is implement the push, the pop, and the top functions, and you're ready to roll. So most stacks, what they'll do is the pop. Some stacks that you build, the pop is taken off the top of the list. And then we'll return the value that's taken off. Some don't work that way. I'm going to make it so it does both. So what I'm going to do is this. So let's see, void push, and we need a item or a T called item. And a pop will be a T returned. And that's going to be something that just returns a T. And then the top is going to return a T. But it's not going to delete from the list. So it's really kind of nice. You know, we've already got all the heavy lifting done. So these functions are going to be very simple to implement. So the push is going to push onto the list in a manner of first in, last out. So that means that I can add rear and remove from the front, just like a stack of plates. Well, no, add front, remove front. That's the stack of plates. So this is going to be this, add front, and what we're adding is item. Yeah, done. Pop is going to be this. Okay, T item equals this get at 0, the top. And then you say this, remove front. Okay. Oh, return T. Okay, and then of course, the top is just the top of the list, the head, but you don't remove it. You just return T. So most pop functions, they don't actually do this T return. They'll just say this remove front. But I like my pops to return what it's actually removing. So if you were trying to go for efficiency, of course you would get rid of this get at, and then just use it in here in the top. Okay, well that's a stack. That's all it is. It's literally that simple. So let's test it for integers first. And remember, we're doing first in, last out behavior. And then we'll test it for customers. So we're going to go ahead and go back to our main. And we're going to create another C stack. We'll just leave this stuff up here and we'll play around with this stuff down here. Okay, so this is going to be I stack. Okay, so we're going to say I stack dot push, and we're going to put the number 9. And we're going to keep doing that. I made a mess. That's supposed to be integer. No wonder it's yelling at me. Okay, there we go. iStack dot push, and let's just go with some random numbers. Okay, that's enough. So let's do a for loop. And we're going to just basically run through the list and print the items. And this is just to check to make sure I don't have any fence post issues. Fence posts are always the computer programmer's bane, or other people would refer to it off by 1 error. Because that get at of 0, I think that should work appropriately, but I'm not for sure. When we do the queue, I may have, maybe not. Maybe the linked list library is built correctly. I'm pretty sure it is. So let's see, there's 4 items. Okay, I++. All right, here we go. All right, so what we're going to do is we're going to create an integer, and that's going to hold our item. Okay, is equal to, now right here I could do stack dot pop, iStack dot pop, and it's going to give me my item. But traditionally, the way that you do this is you get to the top, you assign it to the top, and then do a pop, because not all pops will actually return the item. So we can, but I built mine so we can do it. And that's why I build my own stacks. I stack, cout, I stack dot. Oh, you know what? We don't even need to do that. We can get rid of this. We can just do output the top. Okay, I'm starting to think a little bit. There, that's the traditional way of using a stack. So we pushed, the first Platon was 9. So, in the order of a stack, the 9, it goes on first. And then on the stack, a 3 goes on. And then a 1. And then a 2. So if we're going from the top of the stack, which is the number 2, we should get the output 2, 1, 3, 9. And I'm going to do an end line here. And that is if everything is correctly done, the linked list doesn't have any off by 1 errors, that's what we should get. Okay. All right, I got some bugs. I'm going to work on these and probably let you know what's going on with them. It looks like it's in my linked list, or my stack inherited from the list. Let's see. All right. Oh. Okay, I am going to pause. It looks like I got other issues. All right, I'll be back. All right. Yeah, silly error. It didn't take too long to spot. I forgot my colon there. Typical. Okay. Now a few things here. Return T. Oh, duh. Return item. Actually, you know what? We don't even need that. We can just throw this guy down there. There we go. I already returned T when I should have been returning item. I might have done the same thing here. Yeah, of course I did. Okay, so this one has to be item this time because we're actually removing from the front. Okay. One more. And we're done. Oh. Did I do it again? Oh, yeah, I didn't like that. So, you know what? Instead of returning here, it basically wants me to return a type T. Now there's a way to get around this. It's somewhere in your homework. You just basically say return itself, and that usually deals with it. And it's a weird bit of syntax, but it is in your homework. It might have been in your 162 homework. So now this is an interesting one. Main already defined. Did I take code that already had a main? Did I forget to get rid of code that already had a main? Okay, pause again. Yeah, of course. You know, I forgot that this load save was from our binary save and load video. So that one actually just has to be gone. Okay, so that is, you know, pretty much everything that we've done. It includes everything that we built from our customer list project, added onto with what's called mystack.h, implementation of the stack, and then test of the stack. You know what? If this works, I don't think we're going to do a customer check. I want to show you transactions, the priority queue with transactions, and we're going to build a queue after this, and that one's going to be simple, easy. I probably won't even need to test it. So this one we're going to go ahead and run. If I get my 2139, we are gold. I think it was, nope, it doesn't like that. Okay, I think we have a fence post error. While I look into it, we're pausing. Yes, this is a fence post error in the linked list, and you know, it's not something that's apparent, but what it is we are actually trying to set the previous or the next when it's null. So in other words, we're trying to get a next when we're at the end of the list, and we're trying to set a previous when we're at the end of the list. So what we need to do is we would need to say, no, I'm going to come back. I'm going to fix it, and we'll see where we're at. Actually, I got to thinking that this might be something you want to see how I go about fixing this and what is the problem. So what I would do is obviously use the debugger. So what I'm going to do is show you those steps, and it's somewhere, of course, right in here. Actually, it's right here probably. So I'm going to go ahead and set a breakpoint, and I'm going to find out when exactly does it happen. And I imagine it happens towards the end of the list, or probably on the last pop. So we're going to go ahead and step over. Here's my first pop, second pop, third pop. Now here we go. Here's going to be the fourth pop. We have 2, 1, 3, so we're doing okay. Here it comes with my last pop. There we go. There's where we get an error. So essentially, it is a fence post error as I thought. So let me show you how I would go in and fix this. So what I would do is I would go ahead and do that debugger again, and I would do a step into this time. I would step into the pop function and see exactly what's going on. So what's in here. So what I'm going to do is I'm going to go here to the place where it said the issue was at, which is this set previous, and we're going to go and set another breakpoint. And what I'm going to do is I'm going to go ahead and hit continue once, twice, 3 times. Now we're at the last pop, so we should be right there, 2, 1, 3. So now is our last pop. So now I'm going to step into it. Okay, so we say get at. I'm going to step into this one too. And this is when I'm going to start looking at my memory. I'm going to look at head, and I'm going to see what head actually has. Now this is the last one. So what this means is, well, let's step into it more so that head will actually fill up with data. So everything I've popped off, I've popped everything off except for that one number, which is the last number on the list. So I'm going to do a get at of the last number on, and we see as which should be the next and the previous is null. There's nothing there. And, you know, if you go to locals here and autos, you'll see head. You could also set your own watch, which I would usually do at this time. I would set my own watch and kind of look at what's going on. So here's the head. Next and previous is null. And this is the get at function. So this one actually should run. Okay, so it's going to get the 9 and send it back. So it's the pop that's dying, and that's the remove front function. So there must be something going on with this guy that wasn't implemented properly. You know what? The remove rear might have the same thing. So I'm going to do a step into on this guy. And I'm going to see head shouldn't be null. Should be that number 9 with the previous and the next to nothing. Okay, then we hold that temporary. Okay, so here ntep equals head, meaning this is our front, remove front. And our get next, our next is a null. So it should return just a null and assign null to head. Set previous to 0 when the previous is already at 0. I think that might be it. So let's look into where it actually dies here. And that is the set previous. So head is now null at this time. There we go. That's it. Okay. So it only happens on the last one. If it's the last one, we can't set previous to 0 because head is null. So that if head does not equal 0. Okay, so this is a little fix to your linked list library that you might want to do because you're going to find it. So essentially, if your head is not null, there's no reason to. If your head is null, there's no reason to set previous to 0. So let's go ahead and make sure that we don't have one of these on the remove rear, because that might be something we got to do. If we don't have a remove rear, we don't have a set next. Yeah, there it is. Okay. All right, so yeah, fence post issue. There we go. Well, I'm glad I did some video on that to show you how I'd go about fixing that. So let's go ahead and hit stop. And now we should be able to run this without any errors, and the system pause should work just well. So I need to get rid of this breakpoint and just hit play. Where are you? Oh, nice. We're rocking and rolling. Okay, we're done. That is a stack implementation with a linked list edit of an error. Okay, so now we're going to go ahead and we're going to take this my stack and we're going to make it into a queue. And you know what? I'm not even going to test this one. This one, I'm just going to show you what you would do. So we're going to go my stack and we can just take this whole thing, copy it, create a new one, edit, project, add new item, header file, did it even give me a new header file? What is this one called? No, add new item. I don't even know where that thing went off to. Header.h. Gosh, I gotta remove that. Okay. Okay, so this is gonna be called my queue. And good, add it. Okay. Control V. Instead of my stack, it's gonna be my queue. And what we're gonna do is we're going to, now this is the first in, last out. So what we want to do is we need to, when we push, we should be adding to the rear, not the front. And that's all we need to change. So now, add rear. Okay, so, and then, you know, they get in line essentially. So queue is first in, first out. So it's not like a stack that's first in, last out. So a queue, to implement a queue, your push should be to the rear and your pop and your top should be from the front. So just like a grocery store line. Okay, that's done. I'm not even going to test it. So that's a queue. So now we get into the fun. I wanted to show you how to do a customer sort. And then we're going to do a priority queue. You know what? Let's start with the priority queue. Okay, so that means we're going to take this queue code and we're going to create another one. But this is going to be a PQ, a priority queue for transactions. That means we're not going to template it. We're going to make it so that it's still custom. So you can build a priority queue and have a priority queue through the standard template library. And there's plenty of stuff out there for you to do that with. And heck, I even have an example of the priority queue for you of using the standard template library priority queue. If you go into your modules, let's see here. You go into your modules and you'll see there's code that I posted in the priority queue area. And that is this right here, phase 1 PQ working. That's actually using the standard template priority queue and overloading an operator to implement the sorting. I don't want to do that. Let's do something that's for us or for you. And of course you can use this in your project too, or for your homework for that matter. So we're going to actually create our own priority queue. and we're going to custom it. It's not going to be templated. It's going to be for a transaction. So we're going to say here, add, and then this is going to become PQ. We'll just call it PQ. Okay, now this priority queue is going to be for customers. It's going to use our linked list, but instead of being templated with a T, it's going to take and store a customer. Okay. And you know what? Let's just keep all these functions. And we'll add to them. Okay. All right, now I need to do a few things. I need to include, oh, we don't want customer, we want transaction. I'm doing this for a transaction. Okay, so do I get the transaction? Okay, we're doing it for this transaction. Oh, and this transaction will actually use a priority queue. You can put it on a priority queue because it has the comparison function. So a transaction with, of course you're going to have more stuff in here, but a transaction is going to be based on a time, and that time is going to be based on your epoch value, ticks from 1970. That's how a computer tells time. So we're going to the main thing that a transaction is going to be sorted on is that time component. Of course, you're going to have other things in here such as int account ID, because you're going to want a file just for transactions, a file just for customers, a file just for accounts. And then what you want to do is you're building your own database, so you relate transactions to accounts and you relate transactions to customers through these ID fields. So I'm not even going to fill those guys up. And of course, these should all be private with get and set values to it. So I'm going to then take and implement this transaction in our PQ. It's not customer. We're going to be going back to the customer list soon for sorting. But this we will go ahead and flesh out for our own priority queue with transactions. Okay, now we have PQ. We include transaction.h. Now we need to include not customer. We need to include linked list. Okay, I'm going to take a quick break just to slog down a bit of coffee, and I will be back and we will do our sort function for this. We're just going to add a simple sort function that whenever we push an item onto the queue, we call the sort function, so that the priority queue always sorts based on the time of the transaction. And the time that is first, that comes first, that one should always be at the top. And that's how we're going to build our own priority queue. So I'll be right back. Okay, we're back. Now, just thinking about this sort function kind of gives me a little bit of some, essentially we're sorting a linked list, which is a doubly linked list at that, which means that the propensity to have off by one or fence post errors is quite significant. And when we get done with it, of course, the linked list would be hopefully perfectly complete if we didn't catch all the bugs in the last two uses of it. But there's always a backup plan, and if it gets to be too much, we might resort to it, or you guys can resort to it. But what you could do is you could just take everything from the linked list and throw it onto an array, sort the array, destroy the linked list, and then add everything from the linked list to the array, or everything from the sorted array back to the linked list, which efficiency wise is kind of ridiculous, especially when it coincides to the sort that we're going to be implementing, which is going to be a bubble sort. We're going to keep it simple, and if you want to implement more difficult sorts, as long as you get all the bugs worked out with the bubble sort, you should just now have to work with getting the sort to work properly. So we're going to use a simple sort to begin with. I don't think we're going to be adding any other sorting type functions. Bubble sort's good for the use that we're doing, even though it is the least, the least efficient of all sorts. So I'm going to go ahead and do a void sort function here. And we're going to lay in the, if I go over here to our customer list type, we have ways of progressing. We got the loops set up for traversing the list. And that would be this one right here. So what we need is to do, a for loop will just work just fine. But this is going to get where we start. So let's go ahead and go back to the PQ here. And we're going to implement this, and this is going to be a transaction called temp, and we're going to use temp to traverse the list. And this is going to turn into, since we have a count, do I need to do get count? Probably. Okay, so, and as we know with bubble sort, it's two loops, an I and a J, and you swap in the inside in the inner loop. And for the fence post issue, you got to do a -1 here. Okay, and this we will come back to. Let's actually do this. Let's do a print. Oh no, I already got a print function. It's inside the linked list. I think it is. Yeah, it's in the linked list. Okay, so we don't need this. What we need to do is we need to say, and we're sorting a transaction here. So I'm going to show you how to sort the customer list, which we'll just take the code that we just wrote and use it. So, but we'll be sorting last names. So this is going to be where we actually look at the transactions. So if this get at, no, we want get at 0. So this dot get at of J dot get time is less than this dot get at of J plus 1. So if the first one is less than the next one, then we swap. And if you want to change ascending versus descending, then you just change this back and forth until, I never really keep it right in my mind. I just switch it if it doesn't do the way I want it to do. So okay. Now this is where we swap. And should we swap links, or should we just swap? You know what? Actually, this actually works out pretty good because it's not going to be a nightmare as I thought. We actually just swap the transaction values. We don't swap the links, because the links, with a doubly linked list, that would be a nightmare. So what we'll do is we'll just do an int temp, t temp, trans temp, or no, t temp. That's going to be our temporary value. Set it to 0, and if the next one is lower or greater, then you just swap them. So then I say that this temp, t temp, is going to be equal to this. Okay. And I say this guy is equal to t temp. Oh, wait. Time is equal to the next one. That'll be okay. So the one that I store in temp is the one that I need to overwrite with the next one. And then yeah, we're swapping them. Why is that being a stinker? Oh. Oh. It's not allowing me. That is interesting because it's... Oh, we're returning a value. Okay. That's going to be a problem because the get at just returns a value. So it's not right. It's just read only, which means that we need to make the get at function write capable. That's going to be interesting. So that means we have to actually, the get at function, we've got to pass an address instead of just a, well, what does the get at actually return? Does it return the node or just the value in the node? Because this can't be done. So do I have a set at function? Let's go to the linked list and find out. So we're going to go to the linked list. So this is going to be an issue. So we need to probably go into this linked list and do a set at. So the get at, you see it returns a value. So that means that it can't have write only privilege. You know what? This can just be solved probably by doing this. Huh? Return the address? No, it doesn't like that. So we got to return the address. Basically, we need to do how the overloading the subscript operator. We got to do. This is basically the same thing as overloading the subscript. So let's look at the code that does the subscript operator. So what we'll do is we'll do a C++ overload this guy. And what we need is an example of how to overload the subscript operator. And then what that'll do is give us the capability that we need or the syntax and semantics for what we're trying to do. So here we go. Here it is. Well, I thought that's what I did. Okay. Doesn't like it for the linked list for some reason. No, that's probably not going to be possible for us to do. Probably need to do a set at. I think that's what we need to do, is set at, or something like that. Okay, I'm going to pause and look into the fix for this issue, and I'll come back with a solution. Okay, so you know, I went in, and this is why you inherit from a linked list, and then you have full power over that linked list. So we took this dequeue and we inherited from the linked list transaction. Now the issue here is, like, if we want a sort function, which I was working on, and I paused to come back from, you would traditionally overload an operator and implement the source in the linked list with template T. But since we're able to inherit from the linked list and say what we're sorting, we can implement a sort function at this level and work with it without overloading the operators. So essentially this is the bubble sort, and when I left off we were having issues with this area right here, and it came into creating a set data at function. Of course we have a get at function, and if you noticed, it was complaining about an L value when I was trying to do a get data. In other words, I was trying to take a return value and assign a value to it, which you can do with the subscript overloaded operator, but that seemed a little too far, although I did implement it. However, I implemented the set data at function, which is the same thing as the get at function, but instead we're sending in an index and we're telling it what to set at that index. So what I did here is I just created a temporary transaction. This is my a temporary transaction. This is what I'm going to be using to swap. I want to swap the data in the nodes because I don't want to have to redo the links. And this works just fine in this manner. So now I can get the data from the current node that I'm going to use and override that node's data with the data from the next node, and then take the current node's data, or the j plus 1, and take it from the last node. So essentially this is what my swap function, if you're to do this with just normal numbers. Lucy, stop it. I've got a little dog in the background, sorry. So in any case, let me show you the set data at function. And that will conclude our sort of transactions. And it's our own priority queue. So we essentially have now this added to the linked list. And it's a totally appropriate utility function that you might want to have. So you see that I added a get at and a get ref at. You probably don't really need this get ref at, but this is one of the ways that you can do a subscript operator overload. I'm not going to have that. So this is the set data at function. It's very close to the get at function. What you do is you do all the same steps. You get to the node that you want, and then you just call the set data and override it with the value that you're going to pass in. And it's totally okay to be working with type T here, and it works great. So I'm just going to pause it here for a second and pet my little dog, and that's the function that you will be putting in to your transaction list library. So now you have your own priority queue. It's done. You can use it. And what's nice about it is everything's all automated for you. Every time you push, it's going to sort just like a regular priority queue. And then you have your sort function that works just fine. And we're actually going to take this and implement a customer sort here. I got to pause it and get this dog under control. I'm going to pause it here. And you guys maybe stop a frame and pause and get some of that code in there. For some reason it's not pausing. Okay, so now we can implement a customer list sort now that we've got this one taken care of. So what I'm going to do is I'm going to take all this code and we're going to use it in our customer list. So we can just take it all. Well, just, you know what? We just need the sort. And what's going to change for customer is we're going to be sorting it based on last name. So that means we need to use the string compare function. All right, so let's go ahead and go to our customer list. And we have our saving and reading that we did from our last video. And here is our sort. Okay. And now we're no longer using transactions. Actually, we don't need this code. I can get rid of that. We can call this temp. Now let's go back and fix the other one. Oh, incidentally, this is what you need for the standard template library PQ. You build your transaction, but you also add the compare height, and don't forget to put in your print function just to test your transactions for your sort. Okay, so we want customer list type, and this becomes a customer. And I still need to fix that last one from KeyQ. Let's get rid of this guy. Just make it nice and clean. Okay, save all. There we go. Customer list. Okay, now, so here's the issue now with this. We don't need that. I can clean that up somewhere over here too. And I got to clean that up. Okay. Okay, so now we're all getting cleaned up. Okay, so this needs to be changed because when we're sorting a customer list, we're no longer going to be sorting based on time. We're going to be sorting based on last name. But we also need to build some things to make our customer list a little bit more, or our customers a little bit more friendly. So what I'm going to do is I'm going to go away from the customer list type.h, and I'm going to implement some I'm going to implement two constructors. The default constructor I'm not going to do anything with, but this one I'm going to put in your, and you're probably going to want to do like a set last name, set first name, get last name, get first name. But the way I'm going to do it is I'm just going to do it through a constructor. So basically, I'm going to send in, when I instantiate a customer, I send in the ID, and then I also going to send in a string for first name and a string for last name. And what we're going to do is we're going to actually convert those strings back to our C string. So let's go ahead and look at what is done to do that. And we'll do a C++ convert char star. This is what is usually used for a character array and for keywords. Char star to string. Convert char star to string. Oh wait, no, we want to convert string. We want to convert string to char star. Let's see. Interesting. Oh, the string itself has the C string conversion with it. That's right. Ha ha ha. So we just need this. Cool. Okay, so what we'll do here is, this is assuming that you've checked the size and everything of the string. So we'll just say this ID equals ID. And then Control V. We'll just do a key string copy. Now this is deprecated. It's old, so you got to do a string copy _s to keep up with the newer languages. Maybe that might. Okay, so that will work. And this is going to be first name. And the string object already has the conversion for C string. So we're going to just do a string copy from the first name string back to the first name C string. And we'll figure out what's going on with that string copy shortly. It depends on what version of Visual Studio you're using also. Using namespace std, that should be all good. So why is that yelling at me? Probably because it needs a different library. Oh, that should be last name. Oh, yeah, I need a library for it. It should be _s. I just forgot what the library was. All right, let's look at the example. It probably has it. std c++.h. No, that should string.h. Does that have it? It's been so long. Library for string copy. String.h. Okay. And I bet you it's still deprecated, so we'll leave it with the string copy _s. Is it just string? Okay. Well, that should work. Oh, it's backwards. No? All right, I'm pausing again. Try to get that to work. Okay, we are back. Okay, so I've got, pretty much this almost all the way taken care of. The string copy _s is the new stuff that you're going to be using, instead of the normal string copy. And we're going to copy the first and last strings to the first and last C strings. So this is kind of what you're going to have when you're done. So you're going to want to do a set first, set last, get first, get last. This string, this constructor, it's going to make it easier for me to put some customers on the list and then sort them. So what they're going to be sorted on now is based on their last name. So I've already shown you sorting based on transactions and priority queue. Now we're going to implement a customer or customers to sort by the last name. So let's go ahead and go back to our customer list type now, and we'll go into our sort. Now what we're going to be using is we're going to be using the string compare function. And you compare two C strings, and if one is less than the other, it returns a -1. If it's greater than the other, it returns a 1. And if they're the same, it returns a 0. So what we're going to be doing is we're going to be using these within the string compare function, and we're going to be passing it the last name. Now, the last name, I believe the last and the next last, and then we're going to say, is it less than 0? And if it does it in the wrong order, what we'll do is we'll just flip-flop that less than 0 and make it greater than 0. We'll just flip-flop this guy right here to the other direction if it's doing it wrong in the wrong direction. So what we want to do is we want it to be alphabetical. So we've got the string compare of the last names. this get at string compare, this get at j dot last. Now I may need to open that up, so because that says it's inaccessible. So what I'm going to do is I'm going to go back to customer.h and I'm going to say get last. So I'm going to say char star get first, return first, char star get last, return last. Okay. Now we'll go back to transaction.h. Oh, not transaction.h. We go to customer. We've got that all set up. Get first, get last. And we go to customer list type. Go down to the sort function. And we have a few things that we need to change. Okay, so this is going to be get at or get last. And this is going to be, oh no. We're going to compare both last names, right? Yeah, get last. Okay, now the thing is you want to do this so it's not case sensitive. So, why have I got an error here? We're going to need to make a conversion on these so it's not case sensitive. So I wonder if the braces are out of whack here. Oh no, it's my parentheses. Okay. That's simple to deal with. So it might have a problem with this. Yeah, my parentheses are way off. Okay, let's break this down. Here's one set. End of set. There it is. There we go. String compare all the way to here. And if that returns the -1 or the 1, then we deal with it. Okay, so that's good. So we're going to compare the get last, but I need to convert all to, all to uppercase or lowercase. So what I'm going to need to do is surround this with a conversion. So I'm going to need to do char star C++ char star to upper char array. I don't want to have to. I wish there was I think there should be a utility for this. There should be a utility for this. I don't want to have to do it. If I remember right, there was. Should be one. Really? We're going to have to build it? Nightmare. Okay, I'm not going to build it. You guys can build it. That's there's a way to go to uppercase or lowercase. It looks like you're going to have to just use string copy some more and do a 2 upper or 2 lower. You know what? We just have to do it for the last name, so I guess it's not too bad. Should be able to do it just in one loop. Yeah. Right like that. Yeah, okay, let's just do that. Let's do it for one loop. The thing is we want to do this with temporary read-only stuff. So what we're going to do is we're going to say char last one, char last 2. Do char star. Okay. And we will say string copy get last so this is going to be last 1. Okay, and then the same thing here. This is going to be last 2. Okay, then we have to have for loops. And you probably might want to do some utilities or something like that. And we'll use string len. We use string copy underscore s. No, if it's giving us cahoots, the heck with it. Okay, so string copy last 2. String len of last 1. We can't use I. Let's use S. Let's use R and S. And what we'll do is we'll say last 1 of R equals 2 upper. Two upper of last 1 of R. And we do the same thing, but this one we do for last 2. We can use R here also. Okay, so then we compare them after we've essentially got them all to uppercase. Then we compare them, and if one is greater than the other, then we swap the data without changing the original data. That's the key here. Okay, and I think we're ready. We've got our sort function. We started with that transactions, which was the easier one. So now we have the sort function for customer list. So now we can change it, or we can test it, excuse me. We don't need this guy anymore. We're going to come back to our customer list. But this time we are not going to be doing anything other than just creating them. And so now I need customer list.h. And we will do a customer temp. No, we'll just do this. 1 ID of 1 John Adams. And let's make this Nah, I'm not being very, the heck with it. I'm not being very thoughtful. 2. Okay. And then the last one, and we'll test our sort. Okay. So these are add front. I'm putting them in order, aren't I? Jeez. Seriously. Okay, now let's add rear. So the first one is the last name, second one, and so it should be Adams, Branson, Zinn when it comes out, and the sort's all the way done. So we'll do a cust list dot sort. Okay. So it doesn't like the string copy, so let's do the underscore S. Oh, that's interesting. Oh. Duh. Got to put in string.h for that string copy to work. And let's actually go back and just see if string copy will work. I don't know why underscore S is having an issue. Okay, back and forth. Okay, I'm going to pause it and try to figure this out. Okay, well, it looks like I just need to put the size of in there, and it'll take it just fine. So this one's going to be size of J plus 1. Okay. All right, we got it. Oh. Oh, doesn't like me using that. Okay, so is equal to 0. Because they're just pointers. So you can just assign them to 0. Okay, I think we got it. Nice. Time to test our customer sort. Go back to main. We should get Adam, Bailey, and John. So I think we didn't print. I think we did something on the print. Or no, the sort is having a problem. So I'm going to pause and we'll see what's going on. Okay, we're back. You know what? I've decided that I'm going to leave that up to you guys to do, to get the 2 upper and 2 lower. I'm going to give you the skeleton. This works properly here. And I'm going to continue on with getting this sort function complete, and you guys can do some of the dead work, as I would like to call it. So we're going to go ahead and go with this as the final version. And I tried to keep videos down to an hour in size, and when we get bigger than that, we're kind of going out of scope, which is okay because I got everything in one video instead of having 2 videos. And this is for both stacks and queues, the stacks and queues chapter. Let's go ahead. The sort function is done, and what we're going to do is we're going to test it for the customers. The one thing that we need to do is go to customer and adjust the print function. So we're going to go out here to printing the ID and the first and a space and then the last. Okay, we got the end line. Okay, so now we're going to go ahead and test this. Go to main. We have add rear 1, 2, 3. So we should output, it should be alphabetized if it's working right. It may not, or you know what, if we have to flip-flop it if it's not working right. So let's see what we come out with. Okay, so we need to flip-flop it. So let's see, let's do that. We'll go back to the sort and hopefully this will take care of it. And we'll say greater than 1 or greater than 0. Whoopee! There we go. We got assorted customers. Okay, and you guys can do the 2 up or 2 lower stuff. You know, that's something that is well within your capabilities. And this is kind of an example of how you would go about it. I would go in your own direction though. So I've shown you what a stack is. You built one with me. I've shown you what a queue is. You built one. I've shown you how to create your own priority queue. I've shown you how you need to create a class to use a priority queue, the standard template priority queue. And that is create a transaction class and with it use this function to tell the standard template or library sorting function how to sort a transaction. So you've got an example of a standard template library priority queue, and I showed you where the module was for that. And then I also showed you how to sort a customer list. So, I mean, I think that we did pretty good for 2 chapters worth of information, and I'm going to go ahead and call it done. Thank you.